So in cloud environment, we have infrastructures as a service, software as a service, platform as a service. Infrastructures as a service means, let's say Microsoft Azure or AWS, they providing these infrastructures. So that means we can log in via browser, and after that we can log into their infrastructures and we can create virtual machines, storage, and many other things. So they're going to provide the infrastructures, and with cloud computing environment, we can actually use their infrastructures and configure our services over there. Software as a service is very popular. Let's say any Microsoft 365 product. So they are software as a service. All these OneDrive, SharePoint, Dropbox, Google, they have Google G Suite. So they are all software as a service. That means they're providing the software. We are just purchasing some subscriptions and using for our purposes. So they manage, maintain everything, but we just simply using the software services. Then platform as a service, it means, let's say, this is mostly for the developer. AWS and Microsoft, they have many different kind of platform built up already, is Linux based or Windows based. They have many different kind of platform. So they have many different kind of platform. So top of the platform, we have, let's say, .NET, PHP, Python, those kind of applications can run over there. Now, also we have server virtualizations. Mostly in the data centers environment, we have these server virtualizations. In data centers, we have racks. Let's say inside the racks, we have many servers. Inside the servers, maybe we have virtual machines. And those virtual machines, we configure applications or other services. You can see each of the servers, they have multiple link, and those multiple link goes to top of the rack. This is switches, basically, 2 switches. And from the top of the rack, cable goes to end of the rack. That's a couple of switch. End of the rack, and over there we have, yeah, this is end of the rack. So each of the sections we have separate rack 1, rack 2, rack 3, and each of the rack we have separate servers. Inside the servers, we have virtual machines running, and those virtual machines accessed by, let's say, customers, developer, operators. They log in via GUI or API. GUI means graphical user interface. API means application programming interface. With that, they logged into those servers and then they make some changes over there. These days, majority of the services running in the data centers, and over there, like, we have a big network. Now, spine leaf architectures in data centers. Spine leaf architecture is typically deployed as 2 layers, spines and leaves. Spine is a aggregations and leaves is access layer switch. You can see this is the terminology similar to access layer switch. Over there, we have all leaf switch, and router, servers, and other services, they connected with leaf layer switch. And leaf switch is connected with spine switch. And you can see each of the leaf switch, they have multiple links connected with spine switch, right? In this way, like, if something happened with one of the spine switch, they will have connectivity with the other spine switch. Now, controller-based networking. This section, we can look at software-defined network, automations and programmability. Automation impacts on network management. Compare traditional network with controller-based networking, and controller-based and software-defined network architectures, overlay, underlay, fabric. software defined access HDAccess, digital network architectures, DNA center or DNA. These are the topics we're going to have a look. Now, why SDN? SDN is a software defined network. So with SDN, we can configure uh, many stuffs. Uh, so instead of configuring each of the device with this one, many automation tasks will be able to do with the software defined network. So network devices forward data in the form of messages, typically data link frames like Ethernet frames. So network programmability and software defined networking take those ideas, analyze the pieces, and find ways to improve them for today's needs and reassemble those ideas into a new way of making networks work. At the end of that rearrangement, the devices in the network still forward message, but the how and why have changed. Now, HDN is a soft technology that separates the control plane management of network device from the underlying data plane that forwards network traffic. So software-defined network, with that, we can perform many control plane management functions. So those functions, including many layer 3 activity, will be able to perform with this software system, software-defined network with that. In our network environment, we have 3 different planes: data plane, control plane, and management plane. This is similar to OSI layer we have looked at. It's similar to that. These are the different plane we have. Now with data plane, you can manage uh, all the layer 2 types of configurations, like it's related with switch. Let's say data plane is located in here. We have forwarding table. Mostly switching device, they perform this data plane functionalities. Then control plane with that mostly all the routing type, static route, OSPF, IP routing, all these routing type you can manage. And then with the management plane, you can manage login and all this stuff. So there's a CLI, there's a GUI, with those stuffs you can manage. Now, in this way, we have 3 different sections, right? Data plane, control plane, and management plane. Now, what is data plane does? It refers to task that a networking device does to forward a message. In other words, anything to do with receiving data, processing it, and forwarding that same data, around that areas data plane will function. Common data plane protocols functions include de-encapsulating and re-encapsulating a packet in a data link frame. Routers, layer 3 switches, they have these steps. Adding or removing an 8021Q trunking header. Routers and switches, they have these steps. Matching an Ethernet frame's destinations media access control address to MAC address table, which is layer 2 switches. Matching an IP package destinations IP address to the IP routing table, which is routers, layer 3 switch, they have these steps. Encrypting the data and adding a new IP header for virtual private network, VPN processing. Now changing the source and destination's IP address for network address translations processing. Discarding a message due to a filter, access control list, port security, etc. So data plane, they mostly in layer 2 environment, many features they mostly manage. Control plane, they're mostly related with layer 3, let's say all the routing protocol configurations, OSPF, EIGRP, ARP, NDP protocol for IPv6. Those are the things related with control plane. Also, switch, MAC address learning, spanning tree protocol functionality. So these things, they're related part of this control plane. And then management plane, Telnet and SSH are two of the most obvious management plane protocols. To emphasize the difference with control plane protocols, think about two routers, one configured to allow Telnet and SSH into router and one that does not. Both could still be running a routing protocol and routing packets, whether or not they support Telnet and SSH. So you can see that this is a more on management part. So data plane, control plane, and management plane. Three different parts we have. This is we're talking about more on controller-based networking. In controller-based networking is basically these are the architectures, or these are the terminology we have. Traditional versus SDN architecture. So traditional network architectures, we have, you can see that every network device we have control plane and data plane functions. But in SDN architectures, every device we have the data plane. But control plane is management with some applications. Like every device, you do not have the data plane, but data plane will be managed by some applications. Like control plane will be managed by these applications or software system, but data plane will be there. Now, controller and software defined network. Controller looks like this. This is called SDN controller, software defined network. Part of this, we have southbound interface and northbound interface. With southbound interface, you manage all this stuff like OpenFlow, NetConf, PSAP, BGP LS, OV, SDP. These are the protocol. They mostly deal with this network device. On the other side, northbound interface, we have an API. Part of that, we have a REST API, Java API, etc. So with those API, you're managing all these applications. You can see that northbound interface with that manage applications, and southbound interface you manage the network devices. So with this controller, you can manage all the network device as well as you can manage your application part. So two areas you have control. Now there is a southbound interface. In a controller-based networking architecture, the controller need to communicate to network device. So basically, southbound interface communicate with the network device. Let's say mostly is communicate with the switch and with the app, even with the application programming interface or API. With that, you'll be able to manage the switch. And northbound interface with this one, you can also access this one, but with this one, you mostly manage the applications. Two different southbound network devices and northbound with that you manage applications. Let's say some virtual machines is running, some application is running, those applications you are managing. Now, programmability and SDN. There are three different SDN and network programmability solutions available from Cisco, and they give a wide range of comparison points, such as Open Daylight Controller, which is OpenFlow, Cisco Application-Centric Infrastructures, which is ACI, and Cisco Epic Enterprise Module, which is EPIC-EM. So these are the solutions available, separate solutions, some of them from Cisco, some of them from outside non-Cisco as well. There are different kind of SDN solutions we have in the market. Now, comparing traditional network with controller-based networking. So traditional network, every single thing you have to configure, you log into that device, you configure that. But controller-based networking, maybe with one controller, you're managing many stuffs. For example, yesterday we have looked at WLC, right? With the WLC, we manage many different lightweight access point. In here, with the controller, with the SDN controller, we'll be able to manage many different router, many different switch. We can configure, we can monitor, we can manage like that. Around that areas, we have SDA, which is software defined access. Then software defined WAN, SD-WAN. Then application centric infrastructure. This changes the operating paradigm in many cases, with the controller determining many device specific details. The network engineer does not need to think about every command on every device. The controller configures the devices with consistent and streamlined settings, and the result will be faster and more consistent changes with fewer issues. That is the advantage. The controller-based networking, this is the advantage we have. Consistent change will be able to do. Now, software-defined access or SD access. So this is one of the network architectures or solutions. In SD access, we have all our traditional network. Let's say we have access layer switch and all the device we have, and then we have distribution layer switch, and then we have core layer switch. Right? Access layer switch, distribution layer switch, and core layer switch. So access layer switch is basically, it's all the PC and other things connected, maybe some IoT device, light, camera, etc. It's connected. Then we have access layer switch, distribution layer switch, and core layer switch. In addition, we have another thing called DNS center. DNS center is DNS stands for digital network architectures. With that, you can do many different set of configurations. You can apply many policy. You can perform many automation task. Also, you can check insight and details. Monitoring, basically, monitoring part. So with the DNS center, pretty much you can manage everything for your network. So in software-defined access or SD access, what we have all the traditional network, but new things we have, that is the DNS center. Correct. So pretty much you have all the stuffs you have, all the switch, router, everything we have, but new things we have called DNS center. That is the software-defined network or SDN solutions. Yeah. So it's, yeah, you need to purchase a new device. So this is a separate device, DNS center SIM. So SD access, part of that we have overlay, underlay, and fabric. These are the terminologies. So in SD access network environment, these are the terminology we have. So let's say underlay network means all underlying all the network connectivity. Overlay network means top of this underlay network, you create another network that is called overlay network, like VXLAN, or maybe in our context, we had VPN connections, right? They are like overlay network because they actually, those network they rely on another network and then they are providing the services. So those are the network called underlay, and the VPN and VXLAN, this kind of uh, network, we call it overlay network. And fabric means where everything is connected together, then we call it fabric. Now Cisco DNS Center exists as a software applications that Cisco delivers pre-installed on a Cisco DNS Center appliance. So this is a separate appliance or device. The software follows the same general controller. You can see there's a DNS centers in here, and with the DNS center, one side you're managing all the network devices. It supports Telnet, SSH, all these traditional protocol. Also, it supports Netcon, Prestcon, those kind of new protocol. Also, on the right, on the south, this is a southbound. On the northbound interface, you can see we have the REST API. With the REST API, you can manage other applications. So pretty much this is a controller. Now Cisco DNA controller is their actually SDN solution. So basically it has many features. You can Cisco DNA Center includes a robust northbound REST API along with series of south API. The API you can log in and you can make some changes with your application. You can think of these two categories, like protocols to support traditional networking device, software versions such as Telnet, SSH, SNMP, all these stuffs we have, and protocols to support more recent networking devices, software versions such as NetConf, RESTConf, etc. So Cisco DNS Center needs the older protocols to be able to support the vast array of older Cisco devices and OS versions. Over the time, Cisco has been adding support for NetConf and RESTConf to their more current hardware and software. So that means it supports traditional protocol, it supports some new protocol as well. So it has many different features. Let's say with that DNS centers, easier initial installation, simplify the work to implement features that traditionally have challenging configurations, and use tools to help you notice issues more quickly. So you can configure, you can install, you can identify the issues, quality of service features, you can configure monitoring, device 360, client 360, network timetable. Can find the history of the event, path trace, it discovered the actual path packets would take from source to destinations based on current forwarding tables. So DNS centers, it has a lot of features, basically. This is one of the important things we have. Like when you talk about SDN, software defined network, bit of automations around that areas, these things Cisco invented, basically. Yes. Yeah. Now, this section is going to look at understanding REST and JSON. Understanding REST and JSON, this section is going to look at REST API and JSON, how they functions. Understanding REST and JSON. To automate and program networks, some automation software does several tasks. The software analyzes data in the form of variables and makes decisions based on the analysis, and then may take actions to change the configurations of network devices or report facts about the state of the network. The defined automation functions reside on different devices. The network engineers device, a server, a controller, and the various network device themselves. For this related automation process to work well, all these software components need useful, well-defined conventions to allow easy communications between software components. So it's saying that different component we are using different sort of language. Let's say PowerShell, normal shell. There's a CLI command prompt. Different commands we are using. Different devices. But if we have a well-defined communications method, then across the board you'll be able to communicate all the devices with the same language. So API is one of the tools. With that, you can connect to the server and you can make some changes with your applications. These days, many different applications, they have this kind of API. API, how they functions, they work through the browser, and through the browser you can apply some command. At first you need to log into the API address, and with that, let's say this REST server you have. These servers need to have it may have some applications. Then applications need to have some API. We open the browser and put that API. After that, we'll be able to log into that API. Once you log in, then we can provide some instructions to that particular servers. And REST, how they function, they do HTTP communications, and with the HTTP communications, they send some instructions, they display something. We call that one CRUD operations. CRUD stands for create, read, update, and delete. So you can perform CRUD operations. CRUD means we can create something, we can delete something from that applications, we can update some of the stuffs. So create means we need to use post command. Read, we need to use get command. Update, we need to use some kind of like a patch or put this kind of command. Then delete, so we're going to delete something. So this kind of command can be used.
Have you seen like all the hype recently about the OpenAI? I think the APIs are moving faster than Meta network API. I think it sounds similar to this.
Yeah. Which one? You mean that it's kind of like AI, or?
Yeah, it's like AI really small. It's open source. Use that platform.
Yeah, GPT AI, right?
Yeah. There's like everyone, I think, network. Sounds.
Oh, okay.
One day there'll be one.
Got it. Yeah. Now let's say API related. Microsoft, they have a kind of like a API. Microsoft, this is called Microsoft Graph API. Inside the Graph API, you just need to know the API address, and then you can log in. Once you log in, after that, this is the API interface, and over there, you can see that on the top, you have a get, post, put, patch, delete. All these options you have. Like get means I want to know some information, so I can run a query. It will send me the information about this person. Oops. Yeah, let's say you just this is the address, Microsoft Graph API address. Once you log in, then we have this get options, post, put, patch, delete. These options we have. Get means display, post means if I want to make some changes. Let's say post means, then yeah, it's not working because I don't have options to make any changes in here. Put, delete, but get I have, I have read-only permissions. I can log in. There's a login options in here. Then into put username and password to log into this portal, let's say. But at the moment we have a sample. So with the sample, pretty much you can see everything. Yeah, this is the photo of the user is showing here. This is the sample. Get mail, run query. It will show you the mail, email address and all these details. List an item in my drive, showing this item as well. So you can see this is the API for that Microsoft applications. If I log in, I can see my, OneDrive or Office 365 related, details in here. So this is kind of like an API. You can do many tasks. There's many different tasks. So Microsoft, they build this, platform, and all the Microsoft applications, they are somehow connected in here. And when you log in, then you'll be able to log into your applications. And then you can perform this task: get, post, put, or patch, and delete. This task you'll be able to perform. And all this around here is written in JSON format. So JSON is a JavaScript object notations. In here, you can see that JSON format is kind of like one of the format you can declare everything, and you can read from here. Everything is written in JSON format. There are other format we have, like code snippet. You can see PowerShell, Python, PHP, right? Many other options we have as well. Okay. That's API basically. So with the API, you can perform this task. So data modeling language we have JSON. JSON is JavaScript object notations. Origin from JavaScript language, RFC 8259. We have general, central purpose, general data modeling and serializations. REST API, they're using this JSON language. Then XML is extensible markup language, World Wide Web Consortium, data focused text markup that allows data modeling. REST APIs, web pages, they're using this XML format. Then YML ain't markup language, YML.org, general data modeling language, Ansible, they're using this model. So these are the three different language you have, but JSON is very popular in this environment. Like API world, you go to API, you log in, you configure something, you basically can do those tasks. Get, then put, patch, delete. Those are the tasks you'll be able to do. So JSON JSON format. This is the JSON format basically. Let's say this is one of the small applications called Postman. Over there we have same thing like get, put, post. Those are the command we have. We just need to put the this switch API, device API, and then say get and send. After that, it will display you the device details. Let's say we do show run and we check everything. Similar way, if you do with the API, you can log into your switch, and then after that, you can see these informations. Let's say is a Cisco Catalyst switch, access role, MAC address, name, all these stuffs you can see. You have the curly bracket, close with curly bracket, and you can see after every line, we have the comma. So this is the JSON. JSON is a data modeling language. Now in the cloud environment, let's say you create one virtual machines or you deploy one applications. All these things we are doing in the cloud environment. In the backend, we have this script. All the script is in JSON format. Anything you do, any configurations you do in the cloud environment, that's we do in graphical environment, but same time you can see the all JSON format as well. AWS and Microsoft Azure both environment. That means JSON is very popular at the moment. It's one of the standard language across the board. XML we are using for quite a long time in the web environment. XML, it will have a tag. You can see always start and end tag. This is kind of like a bracket, but start tag and end tag we have. I guess start with response and close with response. Family and family tag. Host name, interface, right, role, all this kind of tag we have. Now, why AML? This is another language. Basically, why ML can be used for the data modeling purposes as well. This one also written in this format: name, host, versions, CLI, host. Inside there's a inverted comma and double curly bracket. In this way is actually written. Now, understanding Ansible, Puppet, and Chef. Device configuration management, challenges and solutions. Configuration drift becomes a much bigger problem if using only traditional manual configuration tools. For instance, the on-device manual configuration does not track change history, which lines changed and what changed on each line, and what old configuration was removed, who changed the configurations, when each change was made. It's saying that device configurations environment basically device configuration challenge and solution. So in the back end, let's say we have if we make any changes with our systems, at the moment you cannot recognize that. Let's say you logged into your router, you make some interface change, but it doesn't document it anywhere. But with the device configuration management, we'll be able to see who make changes, what was the previous versions, all these informations we'll be able to see. So device configurations management, part of that, we have some tools. They're called configuration management tools. Let's say Ansible, Puppet, and Chef, they are the software package. You can purchase each tool, so you can have the free versions of this one. These tools, they are mostly Linux based. Top of the Linux device, you can install this one. Once you install and configure, after that, you can use them. You can use them to push some configurations. Mostly, you can see that in here we have Ansible. To use Ansible, you need to install Ansible on a VM, Linux VM, or Mac devices, because Mac underneath is the Linux operating system. Once it is installed, you create several text files such as playbooks, inventory, variables. Playbooks, these files provide actions and logic about what Ansible should do. Inventory, these files provide device host names along with information about each device, like device roles, so Ansible can perform functions for subsets of the inventory templates. Variables, so using YAML, a file can list variables that Ansible will substitute into templates. So playbooks, inventory, variables, so all these stuffs we have. Now with that, you can configure, you can do some configurations. After that, this inventory file or playbooks file, you'll be able to push towards these devices. Node means it could be server, it could be any switch router around that devices. But main advantage is it's kind of like you can, with this configuration management tools, you'll be able to maintain the version, uh, who, if you make any changes, what was the previous change, you can go back, those kind of advantage we have. So is it more on configuration management tools or device configuration management tools? And these tools we are using for Linux environment for quite a long time, but Cisco trying to, utilize these steps in our Cisco environment, network environment. Now comparing Ansible, Puppet, and Chef. Term for the file that list actions like playbook, manifest, recipe, run list. These are the tools we have. Protocol to network device like playbook, Ansible using SSH netconf, Puppet and Chef they using HTTP and REST API. Use agent or agentless model. Ansible agentless, but Puppet and Chef using the agent. Push or pulled model. So there's a Ansible using push, Puppet and Chef they're using pull model. Similar to Ansible, Puppet and Chef also available. They are similar based on the convenience, people using these tools. So overall, in these sections, we have all these small component. Let's say software-defined network. What is software-defined network? What is SD access? What is overlay, underlay, and fabric network? What is a DNS centers? What is SD-WAN? SD-WAN is a software-defined wide area network. So this kind of device we have looked at is kind of like a plug and play. It's similar to VPN connections, but yeah. So SDN or software-defined network, like this kind of device with that, you can create like similar to side-to-side VPN. You can create simple WAN connections as well, plug and play type of connections. So SD-WAN means you have a wide area network connections. Uh, with SD-WAN is one of the features supported by many router. With that one, you can configure, you can monitor, you can do all the systems. And REST API using HTTP method, and they using JSON, mostly JSON language they using in order to do the configurations, and they perform CRUD operations. Netconf and RESTconf, these are the network configurations and REST API configurations. So basically, they are the new protocol. With this protocol, SDN DNS center can manage network devices. Ansible, Puppet Chef, they're mostly configuration management tools we have. So pretty much, these are the informations we have in these sections.